So this is a really great question. I actually, as an experimentalist, teach my students that the rigor with which you determine uncertainty defines the quality of a measurement. That might be worth thinking about for a second. But let me give you a demo. Specifically, I'm going to use this pen. It's a simple pen, and you might think it's got a fixed weight, a fixed width, a fixed length, and these numbers are fixed. They are some number. Whatever the number is, that's the truth. Well, statistics would say there's a lot more to it than that, and it might not be obvious until you actually think about the process of quantifying what those numbers are. So I've got a tape measure here, and I can give you a quick little demo of what if I wanted to measure the width of the pen, say right there. I could put it up against a tape measure, and I could say, oh, well, it goes between those two marks. But what happens when it's not exactly on one of the marks? It's not right at the one above it or below it. It's in between. How do you communicate that? You can say, well, it could be above or it could be below. Maybe it's right in the middle. Maybe it's closer to one side than the other. How do you communicate that when all you have to measure is a simple tape measure? Well, one approach might be do a more precise measurement. So one thing you could do is you could use, say, a micrometer. And you could say, well, I'll measure it with a micrometer. This will get me really precise. And you will get much more precise. You take your measurement and you say, oh, well, right there, that's the thickness. But if I did that multiple times, even then, I would start to get different numbers each time I did it. Looking down at these significant digits, each time I'm getting different numbers. And maybe I actually am measuring a different point, but you really can't say that definitively because this micrometer only has so many significant digits. So even that last significant digit is either going to be rounded up or rounded down. And so that's often how we would communicate the uncertainty. We would do multiple measurements. You could have multiple people do it, multiple micrometers with independent calibration. And maybe there's a different temperature that'll cause this to expand and contract. And so there's a lot of things that can cause a bias to that value. And so the bias and the calibration, the reproducibility, all of these things contribute to the uncertainty of a simple measurement, like what's the width of the pen? And you might not care about the width of a pen, but anything else you measure, you have those same kinds of issues present when you're dealing with it. And my phone rang, so it's probably time for me to call it good. Thanks for asking the question. Have a good day. Bye.